Hi all, welcome to Public Cloud Design Tips and Tricks. Today's topic is AKS security considerations. It's a little bit a complex topic, but I try to cover the basic high-level view of how it works actually. What is the problem statement? The problem statement is how to secure an application running in Azure Kubernetes service. Now, before we jump into the security aspects, let's a little bit discuss about what is Azure Kubernetes service. AKS is a managed Kubernetes offering from Azure. What it does, it simplifies container-based application deployment with reduced complexity of deployment and operational aspects. Now it has two parts. One is control plan and the other is nodes basically. And the Azure platform in a nutshell manages the AKS control plan. Okay, and the customer managed nodes are managed by the customers within their own network scope, and uh, basically consumer only pay for the AKS nodes responsible for running their services. Okay, so that is how you can define. I've already explained it has two parts: control plane and worker nodes or nodes. So control plane has the core Kubernetes service and orchestration capabilities, and the nodes are responsible for running the container applications basically. Okay, so that is how you can define. Primarily, there are four parts within control plane and also four parts in the nodes area. So what is API server? API server tells how the underlying Kubernetes APIs are exposed. Example we use to access API server using kubectl tool basically. etcd maintains the state of Kubernetes clusters. It's a more a key value pair store within control plane. Scheduler decides which node start which workload, and the control manager is more responsible for operational work within or directed to the nodes basically. So that is how you can define control plan. And then within the node, kubelet is an agent that processes the orchestration capabilities within the nodes. Proxy always creates a virtual network scenario where it's more a delegation or routing techniques to the underlying pods for the request, for an incoming request. And the runtime is more a ecosystem creations to run the container applications. Okay, so that is how you can define on a high level. And now, whenever you work with Azure, Azure Active Directory is an identity provider, and that comes well hand in hand within Kubernetes service also in Azure Kubernetes service. So how it works whenever a user fast start talking to a Kubernetes cluster. So for example, AKS get credential, it goes to Active Directory and try to get it authenticated with the user information within the Azure AD, so that eventually updates your kubeconfig with the necessary secret informations like the certificate to connect to API server, and then uh, the necessary access and refresh token in the form of job token, okay, for the next level verification. And once it gets updated for the subsequent access to the API server, gets validated with Azure Active Directory, uh, and then subsequently based on the K8 RBAC, then you the consumer get access into inside the clusters or the nodes, you can say. We'll discuss in detail in the subsequent slide. Now coming to RBAC in generic, which is most important within Kubernetes scope. Role-based access control deals with who to access the resource and what a consumer or user can do with the resources. Now there are two kind of RBAC comes into play when you start working with Azure Kubernetes service. Is Azure RBAC, which is more on a upper level, is an authorization system that deals with providing fine-grained access to Azure resources. And next is the Kubernetes RBAC, which is an authorization system, deals with providing access to AKS clusters. Okay. To simplify this, I took a diagram from Microsoft itself. I have given the reference as well. So if you see the flow, uh, when a user start requesting API request, then first is the authentication step, that which we already discussed with all the necessary secrets. It's get authenticated, and then once it gets authenticated, then your Azure RBAC and Kubernetes RBAC comes into play. Okay. Uh, That also the authorization step we'll discuss in the subsequent slide, how the role and role binding happens actually. So that is how it works. And now it's a high level diagram how the RBAC cluster role and role binding happens. So let's start with the steps first, then we'll come to the diagram. So for that, the bare minimum steps are like, first you have to create an AD group. Okay, so within Azure activity we have to create a group, then we have to create a role. Okay, and create a role and the role assignments. And then we have to create an user, and then we have to include that user in the AD group. Okay, so user will be authenticated using AD in the first call that we have already discussed, and then the role binding and those things happens actually. So if you see the examples, again I have taken these examples from a blog actually, Kubernetes blog. So if you see that first we have within Azure Active Directory we have to create a role. The second step is a cluster role. Basically, we have to provide a name of the cluster role. Let's say it's a more a read only role, a case read only role. So the verbs are get list, what that is more read permissions basically we are giving. So that is how we can create a cluster role. It's form a YML file, and then once that is gets created, then the group that what we have created in the Azure Active Directory. Okay, so that is more when you create a group in Azure Active Directory, you will get a object ID for that group, and that object ID should be align or assign to this or to be bound with this cluster role in the second step. The second example is, if you see there is a role binding gets created, and the there is a name for that role binding, and then the subject is here the subject is nothing but the object ID that gets created in the step one. Okay, so it's now we are actually combining cluster role with that particular object ID, and that object ID or the group AD group has a user, okay, which we have given in the fourth step, assign the user to that group. Okay, so that is how the user within that group gets access to the cluster services. Okay, Kubernetes cluster services. For example, that kubectl get nodes. Okay, so now you can compare these steps or align those steps now into this diagram. So the left side is more a user and active directory. So we are creating a group actually within Azure Active Directory, and we are also adding a user to that user group. Now when that user connects to kubectl, connects to the API server using kubectl from their laptop, from its laptop, then the first step is it gets the cached credential basically, which is the first time stored in the kubeconfig with all the necessary token, and gets verified with in the Azure Active Directory when it talks to API server. Okay, so, so it gets verified, and then this comes into picture. This cluster role and cluster role binding. So basically, that particular user is connected or assigned to that particular user group, which is bound to a cluster role with all reader informations that we have seen in the step slides. Okay, so that is how the fourth steps comes into picture. So um, fourth step has that particular user group, and that is bound to the cluster get rules, that read only AKS role. So that is how now you can get access, read only access into the nodes. So that is how it works. Okay. Uh, Now it's more from more on a identity level to coming to the network level. How the control plane security is ensured is there are two. So first of all, API server, which is the main gateway to connect to the Kubernetes cluster, within the control plane has always a public IP and a domain name, and that public IP and domain name can be restricted by limiting access to the specific IPs. So that is more a egress check where you can only specify specific IPs that can access to API server. So that is the first way. The second way is more a private clusters way of working, where you can create a private endpoint to connect to the API server, and that private endpoint, a private endpoint gets a assigned IP from the consumer network. Okay, so that is how it works on a private scenario. So basically, you are creating there is a private link endpoint gets created for API server, and that private link endpoint is connected to a private endpoint from the consumer network. Okay, and then it's ensure the security of the connectivity to API server. Okay, so that is how it works in a private scenario, and that will also ensure more security when a user connect to the domain of a API server. So it gets resolved into private IP, and from there actually it start following the private route. Okay, so that is how a control plane security can be ensured. Coming to node security, there are different way you can secure the node operations within uh, the consumer managed clusters. Okay, consumer managed area basically. So I have depicted few of them. Node authorization is a technique by default from AKS 1.24 onwards. It's a special security protection to authorize API request from kubelet basically. So within the node area, kubelet is the agent that orchestrate the request calls. So the request those are coming from kubelets is ensure ensure protections in this node authorization technique basically. Now node deployment, I've already explained that consumer managed part is always the consumer responsibility within their own private network. So nodes those are running in the Kubernetes clusters are always deployed within that private IP space. So that ensures that it's not exposed to the public area, or it's not assigning any public IP. Node storage is whenever you are creating nodes within Kubernetes cluster, then data storage on managed disks are automatically encrypted. That ensures encryptions of the storage. Node security, normally when we provision nodes basically within Kubernetes, it's more a VM based approach, and VM is more Linux or Windows. So in an cluster, in an AKS clusters, nodes are deployed automatically with the latest OS security configuration and updates that is always managed basically. Okay, so that ensures the security on the infrastructure level on the node. Now there is a concept called tenancy. A tenancy is nothing but you can compare like running multiple services or microservices within AKS clusters. So one services based on the responsibility who is using the service is more a namespace basically. So there are multiple namespaces within one clusters with that actually comes with this tenancy concept, and that also needs to be secured when you are running within a single cluster. So how it will be secured, there are few examples. Right? Network policies are used to control traffic from and into the pods, as well as the pods to pods communication. Now pod identities, which are nothing but managed identity within Azure Active Directory, are used to connect to other PaaS services from the pods. So that is where you can secure that connectivity as well, without storing all the necessary um, user ID password kind of informations. And the secrets which are used within the pods are again managed by the key vault with different best practices. So that is more a secret management techniques. So in a nutshell, there are more also. There are more best practices for the tenancy level security, but I have just depicted three examples. So that is how you can start thinking of how to achieve security within the nodes as well. So again, I have mentioned this is a vast topic, but I have tried to cover very basic fundamentals of how it works. Uh, there are different links available in Microsoft. I would suggest to go through those links. That will give you more fundamentals behind it, and then you can also do more hands-on, and then start aligning the concept into the practical, and then also start thinking of design your clusters. Okay, and that's it for the day. Thank you and have a good day.